Okay, welcome to this session, and in this session we'll be discussing about the Java threads and the basics of how the Java is going to deal with the multi-threading. Fine. So now to start with this, so now when you're going to talk about a thread or when you're going to talk about a multi-threading program, so now it should be able to called as multi-program. If it is going to be a multi-program, in that case or in that scenario, we can think about a threading concept and we can bring in the concept of multi-threading unless your program, what you develop or what you implement, if it is not going to be a multi-program, then talking about multi-threading, bringing the multi-threading into the system, it's going to be waste of concept of a waste mechanism. Hence, the first point is the program what you think now should be able to behave like a multi-program, as well as the system what you are going to use should support multi-program. Fine. So right now I hope you are not clearly understanding what is multi-program and how it is different than an as usual program. I will just tell you in a while, but when you are going to talk about a multi-threading concept with respect to Java or a threading concept with respect to Java, just keep this point in your mind. The program what you build now, think about it is going to be like a multi-program. Fine. And this multi-program, as I told you, should be supported with the system what you are using. Currently all the versions of operating system what it will be available or already in use in the recent times, all those systems will support multi-program. Hence, there is no any restriction from the system or hardware. The only thing is the program what you build right now, think like it's going to be a multi-program. So now I'll just tell you what is a multi-program and how it is different than the usual program what we were dealing all these days. Clear? So with that point, so we can say a multi-program, the program that contains two or more parts that can run concurrently. Concurrently in the sense parallelly. I am executing one part of program at the same time I am going to execute one more part of the same program. Clearly understand this. I have a program in execution. In that program I have got a part which is executing in parallel. In parallel, I got one more part of the same program executing concurrently or parallelly. That is what we call this as multi-program. So now just look at this examples what I have given here. Fine. Now these are the two examples. It is similar program or it is similar execution, and both will give me same set of outputs. Just look in what way they differ. Now this is the conventional way of writing a program. Now this is not a multi-program. The first example what I have been put over here, and this is a multi-program. Now I'll just compare and I will tell you how exactly a program will be a multi-program. Now just look at this program. Now we are going to have a main, and I am declaring two arrays of three elements, and I'm going to have a for loop. So a equals a plus b, and I'm just going to have one more for loop, b equals b plus a. So now just look at these two loops. Fine. And now we'll just move on to this program. We'll come back to this program later. This is a simple program where I'm just adding or doing some addition operation and storing the element back in the same array. Similarly, I'm doing with the array b. Fine. So now just look at in this program, I'm going to have a, the same operation, but instead of using b of I, I'm using some constant. And so now I'm not depending upon the array b to perform this operation. So similarly in this case, I was using array a here, and so I was depending upon the array a to complete the operation with respect to array b. So right now again I'm using a constant, and so again this statement will not depend upon an array called as a. So now doing so what happens? So now these two programs just look at this. Right now, do not bother about what output it is going to yield, but just look at this program. Now this program, whatever the instruction we are going to execute, so this instruction should be executed one after the other. It cannot be executed in parallel. This cannot be executed in parallel because I am using the array A here. So now whatever the content will be updated with this array A should be used in this for loop, and so this is dependent upon this. If I'm executing this in parallel, if I think about this as the execution, at that point I may lose some data here. I'll be using the old value of A if I'm doing it in parallel, and so right now I'm not supposed to do it in parallel. This should be the conventional way of execution, which has got only one part to execute. So just start your execution and execute one after the other statement, and that is why we call this entire block is one part. I'm not able to do into two parts because of the dependency between the statements. When there is a dependency between the statements, you cannot make it as a part, you cannot call it as a part, and until unless you don't have multiple parts in your program, you cannot call this as multi-program. Clear? So now just look at this program. Now I'm going to have, this is a set of processing, and this is not going to depend upon any other parameter or the value, and even the same. So now B is not depending upon this key, so hence now this can work by its own execution line, and even this can work in its own execution line. So now this program I can divide into two parts clearly, because this is not depending on this part and this part is not depending upon this part. Now this is how we are going to talk about a program having more than one part, or we are going to have multiple parts. And if you are able to achieve multiple parts in your program, then you're going to have your program as a multi-program. So right now, whatever the example program you're seeing, this is going to be called as multi-program. Clear? So now hence when I talk about these two programs, a conventional way of programming and a multi-program, and we have got two parts, so which is going to execute in parallel. And so if I'm going to talk about this program conventional way, I'll be having only one line of execution. So start at the main function, keep on executing until I reach end of the main function. Hence there's only one part, hence there's only one execution line, and this is what we were doing all these days. Either a C program or a C++ program or this Java program, I had only one single line of execution. Clear? So but now I am able to achieve a multi-program. I know what is a multi-program, and I am putting my effort to create my program to look like a multi-program. So now the execution line should be somewhat different now, because I am thinking about parallel execution or concurrent execution of my program. As now just look at this. When I start my main program, the execution line is similar to this until this statement. I have got only one line of execution, and as soon as I reach to execute this statement, this is the part 1 of the program which can be executed, and in parallel even this part also can be executed. And so now I have got two lines of execution. Now this is the point where I am going to split my execution, which this two line of execution can execute concurrently. Hence we are going to have one line of execution which is executing the part 1 of your program, and I'm going to have second line of execution which is going to execute the second part of the same program. Now I've got two lines of execution, one line so which is going to execute part 1, and the second line which is going to execute the part 2. Now this is how, when we have got a multi-program, there will be more than one execution line which will be used or executed concurrently in parallel. And this is what we should understand about multi-program and the multiple line of execution. So now, if I'm going to have only a single line of execution, we will just call this as thread. Hence, there's only one thread. If there's only one thread, you will never talk and you will never think about a multi-thread, because there's only one thread. And what is the meaning of calling it as a multi-thread? Hence, if it's a single line of execution, just call this as thread, and nothing else to discuss in this about multi-threading. It is as usual normal execution what you're doing until now. But if you talk about an multi-program with multiple parts which will help you to have a multiple execution in line, then think about it as threads now, because there will be more than one execution, and each execution I call this as a thread. Hence, right now I got two threads here, hence we are going to call this as threads. Hence, when I say multi-threading concept, it's all about a number of threads. Right now, I'm going to have only two threads, the thread 1 and the thread 2. Each line of execution in your program will call this as threads. Clearly understand this. Fine. Each line of execution will be termed as threads. Hence, I'm going to have thread 1 and I'm going to have thread 2. Now, this is what you should understand about thread. And so, if I'm going to have a thread, we call this as single threading. Hence, there is no any meaning for multi over here. But if I'm going to have more than one thread, more than one execution of my program, now I can call this as multi-threading or multiple threading. Clear? And so now with this, now we will just focus on multi-threading, because when I talk about single threading, there's no much to discuss about this. Fine. We'll bring in whenever it's required, but right now we'll focus on multi-threading. So now when I say multi-threading, it is similar to multitasking, but multitasking and multi-threading are the two totally different concepts. It's totally different concept. So we can say multi-threading is a specialized and advanced form of multitasking. So it doesn't mean that we are replacing the multiple tasking mechanism with multi-threading mechanism. We are not doing this. So clearly understand this. Multitasking still exists. Multi-threading also exists. Now this multi-threading is going to be the specialized form of a multitasking. Clear? And that is what we say, the multitasking or the multi-threading is a specialized form of multitasking. So now I'll just give a glance. What is multitasking? And this multitasking has been divided into two parts. When I'm going to say multitask, what is task? It's a job. It's a job, or it's something, a procedure should be executed, or set of statement is to be executed. If you're executing two programs concurrently, if you're executing two different programs concurrently, so we call this as task 1 and task 2. The program 1 is the task 1, program 2 is the task 2, and these two are executing in parallel concurrently, and so we call this as multitasking. Clear? So now just drop out one program, just have the same program. In the same program, if I'm going to have multiple parts, I'll be executing each part concurrently, hence we are going to call this also as a multitasking. Clear? Hence, either you have a different two programs executing concurrently, we call this as multitasking. Either I'm going to have a same program, in the same program I'm going to have multiple parts executing in parallel concurrently, even we call this as multitasking. Hence, now depending upon these two scenarios, we divide the multitasking as two ways, or two methods, or the two different ways of having a multitasking. One is the process based. The first example scenario what I gave you, program 1 and program 2, is process based. Each program is an individual process. process 1, process 2, program 1, program 2, and so on. And if I'm going to talk about executing part by part in the same program, we call this as thread based. Clear? So now process based, that is 2 or more programs executing concurrently. Fine. And if it is a thread based, 2 or more parts of the same program executing concurrently. I hope it's clear now. So now, for example, just to give a real scenario, what is this 2 programs talking about? Now if I go and talk about MS Paint application, it's a different process or different program, and at the same time I can open a text editor. So right now I am recording the screen, and so I am using screen recorder. At the same time I am using PowerPoint presentation also, it is the MS PowerPoint. At the same time I am using 2 applications or 2 processes at the same time, and this is multitasking, and these 2 are process based. Clear? Now if I am going to talk about a thread based, we are going to have one application now. For example, I'm going to have a text editor application is running, and in this text editor, just concentrate in detail now. In this program, I've got multiple jobs to do. The one job can be, I can save the file, I can edit the file, or I can edit the document, I can delete the characters, I can create the paragraph, I can change the color, I can change the font. So different sort of operations what I can perform. And on this different sort of operations, along with this, if I'm going to give for a printing operation, now your text editor is editing the document and as well as printing the document. Just look at this now. The same application, text editor, is doing 2 individual jobs without dependency or less dependency. Hence the part 1 is editing, part 2 is printing. This is what we call this as a thread based. Clear? Hence in the process based, the program is the smallest unit. I am going to have n number of programs, hence the smallest unit is going to be the program itself. And if I'm going to talk about thread based, the smallest unit is going to be the thread. I'll just pick one program. In that program, I'll be having n number of parts. Each part we're going to have its own concurrent execution, and in this each execution we call this as a thread, and thread is going to be the smallest unit. I hope you are clear with what is process based and what is thread based. So now when this is a process based and thread based, there are few advantages. I can say the thread based process or the thread based multitasking has got the highest advantage, or it has got the most advantage compared to process based. Whenever we're going to talk about a thread based, it is going to have a less overhead than a multitasking process with respect to process based. That is what we say. A multitasking threads require less overhead than the multitasking process, because one major point. So whenever we're going to talk about a process based, I'm going to have program 1 and I'm going to have program 2, and both are totally different entity. There is no dependency between these 2 programs. Even for a slight reason, there is no dependency. Hence, the program 1 will be having its own address space to create its local variables, to create the reference variable, to create the object, to store its codes, to store the execution result. Whatever the purpose the memory is required, it is going to have its own dedicated address space. And the program 2 will also having its own dedicated address space. Clear? So in the thread based, now I am going to have same program 1, program 2 with its own dedicated address space. But when I say thread based, you should go in detail of the program, where I am going to have part 1 or the part 2. And so right now I am going to have thread 1 and thread 2, which is executing concurrently in parallel. Now just observe this. So this is going to have less overhead because of the reason because of the reason that whatever the thread 1, thread 2, right now we are going to have two different threads executing concurrently. This each thread is not going to have its own address space. Remember this. Each thread will not have its own address space. Whatever the address space the program has got, the same address space will be shared and used by all the threads of this program. That is where we are going to have the thread 1 is using the same address space of program 1. Thread 2 is also using the same address space of the program 1. Hence, the same address space is shared by all the n threads of the same program. It should be same program. Somewhere if I am going to have thread over here, this cannot share this address space. This should make use of the same program's address space. Clear? So now if this, due to this mechanism of the address space mechanism, clearly we can say multitasking threads requires less overhead than the multitasking process. So now you might have thinking how this is going to be less overhead. Now just look at these three scenarios. Fine. So now when I'm going to talk about address space, it's going to have their own separate address space if it is going to be a program. Hence we call this as heavyweight task, because it should manage its own address space. It should use its own big address space enough to store all the variables of the program, and it should manage the address space also. Whereas at the other end, if it is a threads, it is going to be a lightweight task. Threads are called as lightweight task, which doesn't require its own address space, and it need not worry about how to manage your address space. Hence, for this reason, the process we call this as heavyweight task, and the threads we call at the other end as low weight task. This is the first major advantage of using thread based over a process based for the multitasking. And next, the inter-process communication. So now that is, I am going to have two processes here, P1 and the P2, or program 1 and program 2. Now if I want to have any sort of communication, right now it is not dependent, but I may need to have a communication. I need some data to be exchanged between these two programs for some reason. Fine. So in that case, the inter-process communication is going to be expensive and limited as well, because this cannot use the same address space. I need to use some mechanism. I need to bridge a connection between these two, then traverse the data here and there between this process. Hence we call this as expensive as well as limited. Whereas in the other end, both the threads are in the same address space. The inter-process communication is not so expensive. It is inexpensive as well as it has got n number of functions, and we are not going to limit that, because if the same address space, the communication becomes easy, and even you can have n number of properties of this communication, which we'll see it later. Clear? And the next is the context switching. So now, right now, program 1 is in execution. The program 1 is in execution, and program 2 is waiting to acquire CPU to start its execution. Fine. So now that is where we are going to call about or talk about context switching. Right now program 1 is execution and the program 2 is waiting for execution. And when the program 1 has done its job, or somewhere in between it needs to do some other job like printing job, it will just go out of CPU and it will start printing its document. At that time the CPU is free, it's idle, the program 2 will come into execution, and this is what we call context switching. Program 1 was in execution, program 2 was waiting. Now I have been switched this. Program 2 is in execution and program 1 is waiting for the CPU now. Clear? Hence, so this context switching between the program 1 and the program 2, I need to reload the address space, I need to unload the address space. When I put the program, I need to load the address space. When I take out the program from execution, I need to unload the its address space. And at the same time, I need to load the program 2, unload the program 1. Context switch, I need to load and again I need to unload, and this becomes a costly process for me. Fine, if it is a process based, but if it is a thread based, I need not very much about address space. Address space will be in its position. Only I'll be giving the control or the CPU's execution time for the thread 1, and I'm going to context switch to thread 2. So the context switching between thread 1 and thread 2 is going to be easier now, because there is no unloading a address space and loading a address space, because the same address space is used for the execution of both the threads. This is where the multi-threading with respect to thread based will come into picture when I talk about multitasking. I hope you are clear with what is we call the multitasking threads is less over than the multitasking processes. Fine. So now with this, so process based multitasking is not under the control of Java, because so now if I'm executing a Java program, this becomes an entire different application, and I'm going to have a text editor which is not a Java program, and so Java cannot take the control of a text editor which doesn't know anything about Java, or which has been not deployed or developed using Java. Hence, so Java cannot take care of multitasking under process based. It is just executing a Java program, finish off its job and just go and relax. Hence, it cannot take control of other application program. It's just a common sense. Clear? So, but your Java is going to be in total control when we talk about thread based multitasking. Hence, if the Java program is in execution, Java will be the totally in control of controlling what part is to be executed, when it's to be executed, how it's going to be executed, and when to stop it. And so Java will take complete control when it is thread based. Hence, if you want to have a controlled multitasking, think about thread based. If you don't want to control multitasking, think about process based. But right now, as a programmer, I should think about control. And so let me hereafter discuss only about the thread based multitasking. Hence, when I discuss only about thread based multitasking, it doesn't mean that we'll be having only the thread based. Even the process based also will exist along with the thread based. We'll use process based when I want two different applications to execute concurrently, and we talk about thread based when I want my application to be executing part by part concurrently. Clear? But as a Java programmer, we'll think about thread based multitasking where we can take the control of. Hence, so now we'll talk about this, but just look at this. So whenever we are going to talk about the multitasking, so the thread 1 is in execution and thread 2 is going to be somewhere waiting for the CPU. Hence, so if it is going to be a thread based multitasking and we're going to have two parts of execution, so CPU is going to be sitting idle. So just to make use of this CPU idle time, how we are going to make use of efficient way of making CPU without making CPU to sit long enough in the idle state, we will see how we are going to bring in the thread and what thread will give the CPU, and how we are going to switch context switch between the threads by giving the resource as CPU for execution, and by making CPU is not going to sit idle for long time. Hence, the thread based multitasking, by giving you control, will allow you to even make or use the CPU efficiently without making it to sit for long time, to be idle. Clear? And so now we'll just exactly discuss about what is Java thread model now. Fine. Hence we are slightly getting into the programming phase. Fine. So it will take some more time exactly we start programming in as a multi-threading. So now when I talk about a Java thread model, all class libraries are designed with multi-threading. Remember this, when I talk about Java, by default you are in multi-threading. Fine. You need not activate a multi-threading. You need not inherit a multi-threading into your program, or you need not include or import anything. As soon as you have a Java program, by default you are in multi-threading. That is what all class libraries of Java are designed to work with multi-threading. Clear? And so now with this, at this point, let me talk about single threading. So just we'll keep the explanation simple, and as the explanation go on, as we are good enough in handling a single thread, later on we will see how we are going to bring in more number of threads, and we'll clearly understand the multi-threading concept. Right now, understand how to handle a single thread first. Clear? So when I talk about a single threading, so single threading is going to work with event loop and pooling. Whatever the C program, C++ program, or the Java program with one single line of execution we were talking about, it is going to fall in this category itself. Behind the scene, this is what happens. We are going to have a event loop and we are going to have a pooling. So where the event loop will just be an infinite loop which will be keep on checking whether the execution is going on, or the execution has been stopped, or execution should be resumed, or execution should happen a context switch. All the things will be happening in the event loop, and depending upon this event loop, there will be lot of events happening. Either I need to edit a file, I need to print a file, I need to delete a character in the file, and so on. Hence all the events will be in single event queue, because it's a single threading, and everything is going to be in one single queue. One after other, the execution is going to happen. Whereas if I talk about later multi-threading, you'll be having multiple event queues where I can execute the execution of your program, part of your program in parallel. Right now, when I talk about a single threading, I don't have such feature, hence I need to use single event queue itself. And so now, so once the polling event is ready for execution, event loop dispatches the control to the appropriate event handler. This is what happens. The event loop is infinitely checking whether any event has occurred or not. If any event is ready, the polling will trigger an signal for the event loop, and this event loop is going to dispatch the control to the appropriate event handler. If a document is ready for printing, the pooling event will say I am ready, and it is going to signal for the event loop. Event loop will receive the signal saying it should print some document, hence the print job should be handled now. And so this event loop is going to bring in the print event handler and performs the particular operation. This is what behind the scene it happens when we talk about a single threading or execution of a Java program. And one more important point, during this execution, right now the event handler is handling the job. It is a printing job. So now the job from the CPU has been shifted to the printing job. Clear? So now until this event handler returns, nothing else can happen in the system. Until the job of printing is done, nothing happens in the CPU, because it is acquiring the CPU, it is still holding the CPU, at the same time it is printing a document. So now at the time it's going to print the document, the CPU, we say it has been blocked. The CPU is in the blocking state, and the CPU is idle right now. CPU has been not used by any other execution line. This is what happens if we are going to have a single threading. Hence, waste of CPU time, what I have just discussed. Hence, Java's multi-threading will not use event loop or the pooling mechanism. Your Java program, though it is going to handle a single threading also, it will never make use of the concept of event loop and the pooling. All this will be connected to threads and individual threads, and it's going to handle the entire execution of your program. And so when I say Java will not use event loop or pooling mechanism, Everything is going to be thread now. Hence, a thread can pause without stopping other parts of program, even though one thread is paused because it is printing something. Other parts of the program can make use of CPU and continue its execution. Hence, when a thread is going to pause, so the other part of the program is not stopped. And when thread goes to sleep, it is waiting the printing job to be done. Hence, we say it is going to be in the sleep state, right? It will wake up only when the printing job has been done, and we come back and start editing the document. Hence, so even the sleep state of one thread will not halt the other part of the program to be in execution. Clear? And single thread is only blocked. If a process is blocked by the further execution, only the thread is blocked. So remaining all the threads will be intact and will be in execution line. This is where we talk about Java's multi-threading feature. This is where we are not talking about event loop or the pooling mechanism. I don't want all these things because we are going to talk everything in the form of thread. When I'm going to talk about a thread, so thread is going to be in the pause state. Thread can be in the sleep state, or the thread can be in the block state. That means a thread can be in different states in its lifetime. This is what we call this as the life cycle of a thread or the lifetime of a thread. And so when I'm going to talk about a life cycle of a thread, the first stage of any thread is going to be its creation. Hence we call this as new thread. The thread has been created. And once this thread is created, now we are going to make this thread to be executionable ready. It should be ready for execution. And that is where we talk about runnable. So we have created a thread, and right now we are prepared, or we are making the thread to be ready for execution by allocating different resource, whatever it wants, either a CPU, either some other memory block, or the memory size. So whatever the property or whatever the resource this thread requires, we are going to allocate all those things. And once it is done, we say the thread is ready for the execution, and the thread will be in the running state. The thread was in new state when created. The thread was in runnable state when it was ready for execution. And right now it's in execution. Hence we call this as the running state. And being in running state, the thread can go for the waiting state. It can go for the waiting state. And how it is going to go for waiting state? It can go for waiting state on these three occasions. That is, whenever the thread wants to wait, or thread is going to stop its execution waiting for some other operation to perform. For example, an user should give an input now. Until unless the user is not going to give an input, your program cannot go further. It cannot execute further. Hence, it is waiting for the user to enter an input. Hence, we call this as a sleeping mode. The program will go into sleep mode. Hence, it is going to be in the waiting state. The thread will go into waiting state. And if a thread is executing right now in the running state, and some other high prioritized thread will come to acquire the CPU by pushing it out. Hence we call this as the block state. The thread has been blocked, hence it will go for the waiting state until it can reoccupy the CPU to resume the execution. And we are going to have wait state. If a job should be completed, it has been handed over the job to some other process or some other thread, and it needs to wait for some period. Hence we call this as wait, and it will again fall into the waiting stage. So now from being in the running stage or the waiting stage, I can kill the thread. So once the execution of thread is done, we say it is going to be in the dead state. So I can reach the dead state being in the running while executing when I complete my execution, or the user terminates the process. And being from the waiting also without entering the CPU, again I can kill the thread. I can kill the thread if it is waiting for long enough time, I can kill. If it is sleeping for long enough time, I can kill. Hence, a thread can move to a dead state or a destroy state from the waiting state also. And now, being in waiting, if the user has entered an input, so it should come back to execution. And if the block of some other prioritized thread has been made and it has released, so I need to resume back again. And if the job is completed, I need to resume this again. Hence, from the wait state, we are going to resume the execution of my thread being in the running state. Now, this is what the life cycle of the thread is going to be. Any thread which is going to be active will be in any one of this state in its throughout lifetime. So hence, the thread can be created only once and thread can be destroyed only once. Once destroyed, you cannot use the same thread. You need to create an entirely new thread. That is why the word we are using new. You cannot reuse a thread once the thread has been destroyed or deleted. And once it is going to be in runnable, it is starting execution. Once it's in execution, it cannot go back to runnable state. It cannot go back to new state. It can just keep on looping between running and the waiting state, depending upon this event occurrence and depending upon resumption. So this is what you need to understand as part of the Java basics. So in the next session, we are going to discuss how we are going to bring in the main thread, the main program thread, and how we are going to have multiple thread in our program. So in the next session, we will discuss all these things. Thank you for this session.